हेलो एवरीवन, गुड इवनिंग। कैसे हो आप लोग? हेलो एवरीवन, गुड इवनिंग। कैसे हो आप लोग? चलो, so today we are going to continue our discussion on work and heat transfer. We already had one session on this same topic, but because this is a very important topic, a lot of questions are asked from this topic, so we will have two sessions from this particular topic. Okay, so last session we have in the beginning of this month, and for some reason I had to postpone this particular session. And this session I will continue our discussion. We will continue our discussion on work and heat transfer questions. Okay, so as you can see, the last session was basically scheduled on 8th, but we could not have it because of certain issues. But today we are having it on 15th, and then on 17th we will move to first law for closed system. Again, unsolved previous year questions, unsolved questions from PK. Then next session we will have on 28th, yani ki Monday, and next will be on 28th. So mark these sessions in your calendar and do not forget to attend these sessions. Okay, because PKNAG, as you all know, it is one of the most important books that you need to offer, that you need to refer for your GATE exam. Very important book. Sometimes you get direct questions from PKNAG, and that's why I specially bring you these sessions so that we can practice PKNAG questions for thermodynamics. Okay, chalo. So this is my YouTube classes, and as you can see, these are my app classes. I have already shared the schedule on Telegram group. Okay, so if you are on my Telegram group, you have already received it. If not, then join the Telegram group. Also, if you want to attend these sessions, so on 20, 21st, 22nd, 27, 28, 29, we have app sessions, free app sessions. To attend these sessions, you have to download the app. So download the app using this, scan this QR code or click on this link. Click on this link. So either you can scan this QR code or click on this link. Or if you are too lazy, then what you can do is, below this session, you can see below this session, there is this link. Directly with third, fourth line, you will get this link. Click on this link, directly go and download the app, register yourself, and you will be able to watch all the, attend all the free app classes. Okay. And this calendar I have already shared with you in my Telegram group. You can see all my app classes and YouTube classes. YouTube classes are in orange color. App classes are in white color. So mark your calendar, guys, because now you have to get serious. Exam is just on the door. Then just, that's 2 months ahead. So you need to be serious about your preparation. You need to be serious about these sessions. Okay. And guys, if you are planning, if you are still struggling with your syllabus, then we have started crash course. Thermodynamics is already done. Other subjects are going on. You can join this crash course. If you are targeting GATE 2025 or 26, then new batches are very soon going to be started. You can get all the information by calling on this number. Otherwise, you can directly join the app. All the information is already there on the app. Okay. As I told you, how can you download the app? By scanning this QR code or by clicking on this link directly, you can download the app. Okay. Chalo. And as I told you, I have already shared my schedule on fee. Yeah, I am not very sure. I don't know about fees. You can call and ask. I told you that number. You can call. This is the number. You can call them and ask. I am not very sure about. I mean, I can give you random figures, but I am not particular about the fees. Okay. Exact figure I don't know. Okay. Chalo. So guys, if you have not joined the Telegram channel, join the Telegram channel, because I share my schedule, I share my PPTs, PDF, everything on the Telegram group only. So join the Telegram group. Chalo. Let's start the session after a quick introduction. So guys, as you all know, I think you all know me to some extent. If not, then this is my introduction. I have 6+ years of experience teaching GATE, AE, JE, ESC, PSU, all these exams. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano. 3.5 years of industry and research experience. And my area of expertise is basic and applied thermodynamics and heat transfer. ठीक है, चलो स्टार्ट करते हैं पहला क्वेश्चन, फर्स्ट क्वेश्चन. एंड वी हैव ऑलरेडी सीन सम क्वेश्चंस, वी विल कंटिन्यू फ्रॉम फर्दर क्वेश्चंस. ठीक है, चलो द वेरी फर्स्ट क्वेश्चन. A fluid contained in a horizontal cylinder fitted with a frictionless leak-proof piston. Okay, so what do we have? We have a cylinder and we have a piston here, and we have some fluid in it. And it is continuously agitated by a steer. Okay, and this steer is run by a motor. Okay, now the cylinder dia is 0.4 meter, and during the stirring, when you are stirring, lasting for 10 minutes, यानी कि time of stir is 10 minutes, the piston slowly moves at a distance of, how much distance it travels? It travels 0.485 meter against the atmosphere. The net work done by the fluid during this process is 2 kilojoule. Net work done is equals to 2 kilojoule. Now tell me, what is net work done? तो भैया work output minus work input is my net work. The speed of the electric motor driving the steer, यानी कि N is equals to 840 RPM. Determine the torque in the shaft. Torque I need to find out, and motor power I need to find out. यानी कि shaft power I need to find out. These things I need to find out. So tell me, by I know one thing. What? That power, shaft power or motor power is equals to torque into omega. Motor power is equals to what? Torque into omega. So torque will be equal to motor power upon omega. And what is motor power? It is basically work input that you are giving. Okay, and 2 pi n by 60. So I need to find out this. How can I find out this? So as you all know, net work is 2 kilojoule. Net work is 2 kilojoule. Okay, let me solve it here. So net work is equals to work output, यानी कि what work output? The work done by fluid minus work input. Sorry, it is net work. It is net work. Okay, net work. So net work is 2 kilojoule. What is work output? Work output is the distance traveled by the piston, work output from the fluid, and it is happening against the constant pressure of atmosphere. So it is P dV minus work input. So what is work input? Work input is equals to P dV minus 2 kilojoule. Now what is the pressure, guys? Pressure is atmosphere 101.325 kilopascal. What is dV? dV is area of piston into distance traveled minus 2 kilojoule. So it is 101.325 into pi by 4 d square into L minus 2. 101.325 into pi by 4. D square is how much? Diameter is 0.4. and length is 0.485 minus 2. Now, can you tell me how much is the answer? Can you tell me how much is the work output? How much is this value? How much is this value? So when you solve it, it will be around 6.175 minus 2. So it is 4.175 kilojoule. So this is the work that is going in. Yaar, I am sorry, I don't know. Satya sir, I think he takes class on the EC channel, right? So I am not very sure, yaar. Okay. But I think he is planning. Okay. So you can ask someone on the EC channel. Okay. Yeah, I am not sure. I am really sorry. Okay. ठीक है. Chalo. So this work I have gotten. But you have to understand, I need to find power, not work. I need to find out in kilowatt or watt basically. So for watt, this work I am giving how much? This work I am giving in kilojoule. So now power is equals to what? By work input per unit time is power. Okay. So this is your motor power. So it is 4.175 into 10 to the power 3. Now it is in joule upon 10 minutes into 60 seconds. So now you will get in seconds. How much you are going to get? How much you are going to get? So you will get around 6.92 watts. So now I have gotten this. So first of all, I have found out my motor power. Motor power is what? 6.92. Motor power is 6.92 watt. Now since I have gotten motor power, I can find out torque is equals to 6.92 into 60, 2 pi into 840. Hello, good morning, good evening, sorry. क्या है आंसर? टॉर्क कितना आ रहा है? How much torque you are going to get? You are going to get 0.079 Newton meter is the torque that you are going to get. Yes? Are you getting this? Guys, you have to answer. Okay? And this question is very confusing. A lot of students remain confused with this question. I don't know why. It's very simple. Net work is given. Okay, clear? Now let's move on to next question. At the beginning of the compression stroke, of two-cylinder internal combustion engine, the air is at pressure. So two-cylinder internal combustion engine, air at the pressure, air enters at यानी कि P1 is equals to 101.325 kilopascal. Compression reduces the volume यानी कि V2 is reduced to the 1/5 of the original volume, and the law of compression is PV 1.2 is equals to constant. Now the bore and stroke of each cylinder is given. Okay, so we have two cylinders, K is equals to 2. Bore is given 0.15 meter and stroke is given 0.25 meter. Determine the power absorbed in kilowatt by compression strokes when the engine speed N is equals to 500 RPM. 500 RPM. So if you remember this diagram as well, compression when it is happening, so it happens like this. Okay, this is by constant pressure, then compression happens and then it goes out. So it is not 1, 2, 3, and this process it is saying PV 1.2 is equals to constant, and they are asking work out, power absorbed. So this power input by piston, it is given by piston, isn't it? It is given by piston. So if it is given by piston, so first of all I need to find out work input, then I will calculate power. Okay, so let's talk about work input. By piston is equals to n upon n minus 1, P2 V2 minus P1 V1 is the formula. We all have seen it. We all have seen this formula when we solve these questions. Okay. Now n is known to me, it is 1.2. So can I say 1.2 upon 0.2? P2 is not known to me. P2 is not known to me. V2 is not known to me. V1 is not known to me. So first of all, V1 I can find out pi by 4 d square into L. So it is given to me. Everything is given to me. 0.15 square into 0.25. How much you are getting? How much you are getting volume? V1 that you must get is 0.0042 meter cube. Yes or no? And now V1 you have gotten. So V1, V2 you can get. V2 is V1 divided by 5. V1 divided by 5. So this is how much? This is 0.00084 meter cube. So now I know V2, I know V1, I can find out P2. How can I find out P2? I have this equation. So bhaiya P1 V1N is equals to P2 V2N. P2 is equals to P1 V1 by V2N. Okay. So P1 I already know. How much is it? 101,325. V1 is 0.0042. This is 0.00084 and 1.2. So how much P2 you are going to get? How much P2 you are going to get? This P2 is equals to, कितना आ रहा है P2? 700 kilopascal. So if I got P2, I can substitute here. P2 is what? 700 into 0.00084 minus 101.3 into 0.0042. So work you will get. I don't know how much work you are going to get, but you can find out how much work you are getting. Can you find out how much work you are getting? 700 into 1.2 divided by 0.2. So you will get around 0.974 kilojoule. Yes. This is what you are getting. And now work, they are asking power, not work. They are asking power. So I need to convert this work. I need to convert this work into power. So power is equals to, by work per unit time, and therefore I have 0.97 kilojoule upon RPM. RPM is 1500 RP revolution per second. per second. Okay, it is first of all RPM. So it's 500 by 60 per second. And we have two cylinders. So total power I need to find out. We have two cylinders. So if you can find this out, tell me how much you are going to get. 0.97 into 500 into 2 by 60. कितना आ रहा है आंसर? कितना आएगा? You are getting 16.16 किलोवाट. आ रहा है या नहीं आ रहा है? यस. चलो नेक्स्ट क्वेश्चन देख लो. नाउ टोटल वर्क डन निकालना है बाय दिस गैस फॉलोइंग द एक्सपेंशन प्रोसेस दिस. सो आई हैव टू फाइंड आउट टोटल वर्क. आई नीड टू फाइंड आउट दिस एरिया प्लस दिस एरिया, यानी कि वर्क टोटल इज इक्वल्स टू वर्क ए बी plus work BC. Now AB is very clear. AB is very clear. It is the area under curve AB. So area of rectangle plus BC. BC I need to find out. So BC is polytropic process. What is work? PB VB minus PC VC upon N minus 1. So this is what? It is height 50 into height into width, length. So it is 0.4 minus 0.2. ठीक है. Now see, I know PB, I know PB, I know VB as well 0.4, I know VC as well, but I do not know PC, which I can simply find out. How I can find out? PV BVB 1.3 is equals to PCVC 1.3. So I just need to find out PC is equals to PV BVB by VC 1.3. So PV is how much? 50 bar. VB is 0.4 upon 0.8 1.3. कितना आएगा PC? How much is PC? PC is I think 20 bar. कितना आ रहा है? 0.4 divided by 0.8 to the power 1.3 into 50. 20.3 bar. 20.3. So now I know. So PV is 50 into 10 to the power 5. Okay. First of all, I need to write this into Pascal. I need to write this. Okay. So this is 50 into 10 to the power 5. Now you will get in joule. So similarly, this into VB is 0.4 minus 20.3 into 10 to the power 3 into VC is 0.8 upon 1.3 minus 1. So how much is work total? कितना आ रहा है work total? कितना आएगा? You will get around this total will be around 2.25 megajoule. मेगाजूल. तो 2251 किलो जूल आ गया, तो 2.25 मेगा जूल आ गया. ठीक है, आ गया. चलो नेक्स्ट क्वेश्चन देख लेते हैं. नेक्स्ट क्वेश्चन भी सिंपल है बिल्कुल. सब अच्छे क्वेश्चन है और सब सिंपल. इफ यू अंडरस्टैंड द कॉन्सेप्ट देन दे ऑल आर सिंपल एज वेल एज गुड क्वेश्चन एज वेल. ओके, चलो नेक्स्ट क्वेश्चन. A system of volume V contains a mass m of gas as pressure P and temperature T. Macroscopic properties obey. So this is your equation of state. Pressure, volume, temperature are related like this. A, B, C, R are constant. Obtain an expression for displacement work. What is displacement work? Integration P dV is the displacement work 1 to 2 by the system during a constant temperature expansion from volume V1 to V2. Okay, calculate the work done by the system which contains 10 kg of this gas expanding from 1 meter cube to 10 meter cube. So this is my V1, this is my V2 at a temperature of this. T is this. Use the value A is equals to this, B is equals to this, R. ठीक है, तो पहला तो ये है first. And first we all know for constant temperature what do we have? For constant temperature we all have done displacement work is equals to constant यानी कि MRT1 ln V2 by V1. This is my equation anyway. But for this I need to find out. So to find this out, work displacement in a general term PdV, and it is 1 to 2. Now I need pressure, and what is pressure? You see from this is equals to MRT by V minus B minus A by V square is equals to pressure. So I need to keep this here. MRT V minus A upon V square into dV and V1 by V2. Simple. So I have to integrate this. Okay. So integration V1 by V2 MRT V minus V dV minus A by V square dV. So you can do the integration. You can do the simple integration and you are going to get MRT ln V minus B. ठीक है, and this will be V1 and V2 minus A upon V minus A upon B basically. Okay, V1 by V2. So if you put the boundary conditions, it will be V2 minus B, V1 minus V plus A by V2 minus A by V1. Now you have all the values. Okay, so you have mass, you have V1, you have V2, you have A, you have B, you have R, you have temperature also, you have mass is 10, R is 0.278, temperature is 293 ln, V2 is 10, this is 1, B is 1.07, plus A is 15.7, 15.7 into 10 to the power 4, 1 upon 10 minus 1 upon 1, and you can find out your work. कितना आ रहा है वर्क? कितना आएगा वर्क? कितना आएगा? Are you calculating it? You should get around 1743 किलोजूल. कितना आएगा? Around 1743 किलोजूल. आ रहा है इतना? आ रहा है? चलो आगे बढ़े. नेक्स्ट क्वेश्चन. चलो. A milk chilling unit can remove heat from the milk. So Q rejected is 14.87 megajoule per hour. But heat comes in. So Q in is equals to 4.187 megajoule per hour. To find the time required for cooling a batch of 500 kg of milk from this temperature to this temperature, and Cp is given 4.187. So first of all, you need to find out net heat transfer. How much net heat transfer you need? And that will be Q rejected minus Q in, and that is 41.87 minus 4.187. So what is the net heat transfer you are getting? Around 37 point something, 37.683 kilojoule per hour. ठीक है? Now this is net heat transfer rate. Net heat transfer rate. But how much heat you are removing? Q. Q transfer is equals to mass Cp dt. And mass is 500 kg. Cp is 4.187 into dt is at 45 minus 5. That means 40. And this will be in kilojoule. So how much heat you are rejecting? 43.4 kilojoule. 83.74, sorry. 83.74 kilojoule you are removing. So if you are removing this much kilojoule and this is rejected per unit hour, 37 is rejected per unit hour. So how much time is required? How much time is required? So time required is equals to Q upon Q dot net. And this is 83.74 kilojoule. This is 37.683 kilojoule per hour. And it is around 2 hours. It is around 2 hours. 2 hours 13 minutes is required to reject this heat. Understood? Understood? Yes, guys? Are you able to understand this? Very simple question. Now let's come to the, I think it is the last question. Huh? Okay, second last question. We want to freeze, we have mass of fish is equals to 680 kg. And the temperature T1 it is at 5 degrees Celsius, and we need to reduce the temperature to, okay, fish is at T1, which is 5 degrees Celsius, 278 Kelvin, and we need to reduce it to temperature minus 12 degree. So minus 12 is what? Minus 12 is 259 or what? 273 minus 12, 261 Kelvin. The specific heat of the fish above freezing point is, so let us say there is some freezing point. Freezing point is minus 2. Freezing point is minus 2 means 271 Kelvin. Now above freezing point specific heat is 3.182 and below freezing point the specific heat is 1.717. Also the latent heat of fusion is, यानी कि here the heat absorbed Q latent is equals to 234.5 kilojoule per kg. First of all, how much heat is removed to cool the fish, then what percentage of this is latent heat. So you see, there are, first of all, heat will be added, Q sensible, heat will be rejected here, then some heat is rejected here at latent heat, and then Q sensible 2. This is the total heat that will be rejected. So Q rejected is equals to Q sensible 1 plus Q latent plus Q sensible 2. Okay, now Q sensible 1 is what? Mass of fish, Cp, and temperature is going from T1 to freezing point. Latent heat, mass of fish into latent heat plus sensible 2, mass of fish, Cp, freezing point minus T2 minus T2. ठीक है, चलो, तो मास इज 500 and Cp is 3.182. Sorry, mass is 6. How did I write 500? 680. Mass is 680. Now T1 is 278 minus 271. Plus again mass is 680 into 234.5 latent heat plus this 680. Now here you will use this Cp 1.717 into, I hope I am not hiding anything. Okay, so this is 271 minus 261. Okay, thank you Anu. ठीक है, so this will give you the entire heat rejected, and this is basically around 186.3 megajoule. Now this is the total heat removed. When we talk about fraction, so percentage of latent heat is equals to Q latent upon Q total. So latent heat is this. Latent heat is this, and this is around 159 megajoule by 186.3 megajoule. Okay, so your latent heat consists of around 85% of your total heat rejected. You see how much heat is absorbed during latent heat. Okay, so whenever latent heat is absorbed, basically latent heat, you see what happens, specific heat capacity to absorb heat is infinite, is very high. So it can also transfer heat or absorb a lot of heat during phase change. Okay, chalo. So this is your 85% fraction. Now let's come on to the last question. I will explain you the concept, but you try to do it yourself. Okay, I'll explain everything, but you try to do it yourself. ठीक है, चलो. Now, so now the question is saying a piston cylinder device contains 0 point. So I have a piston cylinder device. It contains volume is 0.05 meter cube and initial pressure is 200 kilopascal. Now at this state, a linear spring having a spring constant is touching the piston but exerting no force. There is no force at this point of time. K is equals to 150 kilonewton per meter. Now you are transferring heat. Now heat is transferred to the gas, causing the piston to rise, and to compress the spring. So when I am supplying heat, piston is increasing, is rising, and now piston will reach here, let us say. Piston will reach here until the volume becomes double. So V2 is equals to 2 times of V1. That means final volume is what? V2 is equals to 0.1 meter cube. Now cross sectional area of piston is given 0.25 meter cube. What I need to find out? The final pressure inside the cylinder, total work done by the gas, and the fraction of this work done against the spring to compress it. 3 things I need to find out. So first of all, final pressure. Tell me. Initial pressure is P1. Can I say final pressure is equals to initial pressure P1 plus when piston moves up, so a force is applied by the spring, and because of this a pressure will be applied. So can I write P dash or P spring? Can I write pressure exerted by spring? Yes. Now P1 is how much? P1 is 200. What will be P spring? P spring by force per unit area. Force of spring per unit area. And force of spring can also be written as K into X by area. K into X by area. ठीक है. Now I know K, I know area, but I do not know X. How can I find out X? As you all know, change in volume is equals to area of piston into X. So change in volume is this. This is the volume change. And it is what? V2 minus V1. It is what? V2 minus V1, which is 0.05. Area of piston is 0.25 into X. So from X you will get here, I think around 2.5. Just check. Okay, 0.2 meter. 0.2 meter you are going to get. ठीक है, this is your X. Okay, so now you know X as well, you know K as well, area also you will know. You can find out plus 150 into 0.2 upon 0.25 P2 you are going to get. कितना आ रहा है P2? P2 कितना है? अराउंड 320 के आसपास आया. कितना आ रहा है P2? 320 किलो पास्कल. Now, very important concept here, very important. You see, you know P1 is equals to 200 kilopascal. and V1 is equals to 0.05 meter cube, and P2 is equals to 320 kilopascal, and V2 is equals to 0.1 meter cube. But how you are going here? You see, if I draw PV diagram, so my P1 is this 200 kilopascal, and this is V1 is equals to 0.05, and P2 is equals to 320 kilopascal, and V2 is equals to 0.1. So I know 0.1, I know 0.2, but how I am going from 0.1 to 0.2, that is the question. Yes, whenever spring is there, linear process happens. You always go slowly, you go linearly. And this is how you are going to go from 1 to 2. Usually they do not give you this, but you need to know this. Whenever spring is there, slowly, so you can assume it is linear process. And when it is linear, so now you can easily find the work. What are they asking? The total work done by the gas. So work total is equals to area under curve. Area under curve. And area under curve. So it is area of triangle plus area of rectangle. So either you can do it individually, or you can do one thing. Same thing you are going to get. Kya? P1 plus P2, 1 by 2, P1 plus P2, and V2 minus V1. Same thing you are going to get. You can do it individually as well, or basically if you simplify these things, you will get the same answer. Okay? So it is 320 plus 200. कितना आएगा? 520 into 0.05. So total work you will get. How much? 520 into 0.05 by 2, and it is 13 kilojoule. Now their final thing they are asking the fraction of work done against the spring. So against the spring is happening what? This area of triangle is happening against the spring. This is the work against the spring. So work of spring I can find out by area of triangle. It is half base into height. So half base is how much? V2 minus V1. Height is how much? P2 minus P1. So again, if you do the same, yes, it is 0.05 and it is 120. It is 3 kilojoule. So they are asking fraction, yani ki work of spring by work of total, and it is 3 by 13 kilojoule. So I don't know how much is this. कितना आ रहा है fraction? %, 0.2307 or 23% is the answer. Okay. So this is the fraction. Okay. Chalo, very good. So we have covered a lot of questions. We have covered almost around, I would say, 15 questions combined today and the last session of work and heat transfer. Okay. Because you see from this, a lot of questions you see in GATE exam. This is the most important and most confusing topic in thermodynamics. That's why I have taken 2 separate sessions for this. And combining both the sessions, I think we have solved around 15 questions, maybe more than 15. And these are all good questions. If you understand the concept, they are all simple questions. And solving pick and R questions is a very good idea before GATE exam. Okay, chalo. Now, we will have the next session on 17th, as you can see in this schedule as well. As you can see, we will solve first law for closed system P and R questions on 17th. Then tomorrow we have this series, you see, good old 90s. So we will solve some 90s questions, previous year questions from GATE, same time 9 p.m. Applied thermodynamics. These are from applied thermodynamics. Okay, thermodynamics session is already done. Thermodynamics session is already done on last Friday. Now this is applied thermodynamics. And then on Friday we will continue our discussion on PK unsolved questions on first law for closed system. Then we have first law for open system on 20, and then we have second law of thermodynamics on 28. So guys, do not forget to attend these sessions. Mark your calendar and join these sessions if you really want to score good in your thermodynamics. Okay, chalo. And all will be at 9 p.m. only. So just remember this. Anyway, I will be posting my schedule on this schedule is already been posted in the Telegram group. If you are there, you already know this. Okay, and to go for these app sessions, download the app. These are all white. These are all app sessions. So to join these app sessions, you have to download the app. You can download the app by clicking on this link. ठीक है, चलो. If you want to attend app sessions as well, free app sessions. Okay, chalo. ठीक है guys. So very nice. Thank you guys so much for being with me and solving questions. It is going to really help you for your GATE exam. Okay, chalo. I am going to see you tomorrow at 9 p.m. where we will be solving questions from applied thermodynamics and previous year questions, very old questions which are still relevant, still important. Okay, not all of them, just important ones. Okay, chalo. ठीक है guys. See you tomorrow. Thank you guys. Tada, bye bye.